Hello and welcome to RX Science. In today's video about science, I'll explain to you three things: isotopes, nuclear fission, and nuclear fusion. We should start now. So what are isotopes? For me to explain isotopes to you, I would need an example. Let's take neon. Neon has 10 neutrons. Also, the atom neon has different versions of itself, such as neon 20. But the thing is, the 20 over here, next to neon, represents the number of neutrons. And you may realize that this atom has a different amount than actual neon. So what is this called? This is actually what an isotope is. An isotope is an atom with a different amount of neutrons than its original. Using what I explained for isotopes, I'll explain nuclear fission and nuclear fusion. But first, I'll tell you some common isotopes that you should know. So, here's some. Deuterium for hydrogen with 1 neutron, tritium from hydrogen with 2 neutrons, carbon-14 with 14 neutrons, and obviously it's from carbon, carbon-12 with 12 neutrons, and uranium-235 with 235 neutrons. Now I'll show you a quick little example and basically explanation. So you have two twin babies. They look exactly the same, but when you weigh them, they're gonna weigh differently. And what this represents is that you have an atom and an isotope. You can't really tell the difference until you look into the nucleus, where you see a different amount of neutrons. So they look exactly the same, but their physical properties is different. This is exactly what's happening with the twin babies. And I'll give you another example. Let's take a car. Let's take Tesla Model 3. So let's say you have a normal Tesla Model 3, then you have the premium version and the dual engine. The model is the exact same, but when you look into its interior features, you will see that it's different. That's also a really good example of isotope. Now I'll tell you about nuclear fission. Nuclear fission is very interesting. Let's take uranium-235, which is an isotope of uranium. It's a very unstable atom because of its amount of neutrons. It has so much neutrons that it's very unstable. Now, if the uranium-235 catches another neutron, it will be so unstable, so unhappy that it will split. The splitting creates two more atoms called krypton-92 and barium-141. Now, if you do the math, you may notice that not all the neutrons are included. So what happens to the other neutrons that didn't get included? They're just leftover neutrons which are left freely roaming. Also, when splitting happens, it releases a lot of energy, so powerful that nuclear fission is used for nuclear power and nuclear explosions. It has that much energy in it when it splits. Here's a quick little example. You have uranium-235 in neutrons. I'll explain it again. So what happens here is that, as you can see, you have uranium-235, a neutron goes into it, it creates uranium-236, and it splits into krypton-92 and barium-141. Now I'll tell you about nuclear fusion. Nuclear fusion is the exact opposite of nuclear fission. If not exact, it's really close to being exact. Instead of separating an atom, atoms combine. They combine to create a stronger nucleus. When you combine hydrogen atoms together, it will create helium. But remember, just like nuclear fission, nuclear fusion also releases a lot of energy. And also another thing to remember is that the combined version of the two atoms actually has more neutrons than either one of the atoms that you started with. So yeah. This nuclear fusion constantly occurs in our sun because, if you know, our sun has a lot of hydrogen in it. So hydrogen is smashing each other in a very short amount of time, and it creates helium, if you know what I mean. they're constantly smashing into each other to create helium. We use nuclear fusion for electricity, And how do we harness this energy? We have a tool called fusion reactor which harnesses the energy. So now I'll show you a quick example of nuclear fusion occurring. So what happened here? As you saw, hydrogen smashed into each other, created helium. This is exactly what happens in our sun every moment. Now I will tell you a quick little summary about isotopes, nuclear fusion, and nuclear fission. So let's go all the way back to isotopes. The main thing here that you need to know is that isotopes of an element is basically the same, but it has different amount of neutrons than its original. Here's some common names, as you can see here: deuterium, tritium, carbon-14, carbon-12, and uranium-235. And here's the animation again. You have twins, and then they weigh differently, which is an example of isotopes. And also remember my car example that I said, that if you have the same model of a car, but then the interior features are different. Now, nuclear fission, the most important thing here is that when an atom becomes very unstable, it splits into two more atoms. Here's the example really quick. Now, nuclear fusion. What I would say about this is that two atoms combine together to create a stronger nucleus, and the nucleus contains more neutrons than either one that you started with. And here's the example. So that would be it for my isotopes, nuclear fission, and nuclear fusion video. Hopefully you learned something new, and bye until next time.